my name is Laura Marie Coleman. Thank you for joining me for this video on how we relate multiplication to area using concrete pictorial abstract progressions, especially in 3rd grade. In this video, we're going to identify a progression of representations that can help students build the conceptual understanding of how multiplication relates to area. Let's take a look at what this looks like. In grade 3, we not only introduce multiplication, but we then have students relate multiplication to area. And this is going to support lots of strategies as they move through the rest of their education, all the way into algebra. So let's talk about what this looks like. At the beginning of 3rd grade, students learn to represent an equal group model in a multiplication equation. So this would be 3 groups of 4, or 3 times 4 equals 12. Once we establish this understanding for these multiplication symbols, they also relate it to division, and then they start to move into multiplication in relation to area. This involves students creating arrays. The first step in creating arrays is for students to physically move objects to create the arrays. So each group in my equal groups becomes one row in my array. Once I've developed a consistent understanding that the equal groups are connected to the arrays because I can see the groups in the rows or columns of the array, then I start to have students draw pictures. So each item in my array will be represented with a dot or object or whatever symbol in my drawing of the array. So because I had equal groups of 4 and I have 4 cubes in each row, my drawing of the array has 4 dots in each row and 3 rows of 4 dots. These two representations are very helpful for students because having physical space between the objects or dots in the array helps them see each part or each item in addition to looking at the whole. When we increase the complexity, we can take away the space between the dots or the objects. So I could take all of my cubes in my array and put them together in a way that shows no space in between them. And if I was going to transition my drawing, I could also draw a tiled rectangle and use a grid that shows each item in my array without spaces between the items. The final step in the connection between multiplication and area, moving to the most abstract model, is when students can understand a rectangle without the grid labeled with side lengths and infer that it means that there are 4 units in each row or 4 units across and 3 down. Let's review the stages of the progression that you just saw in the video. First, the students started with an equal groups understanding of multiplication. Students then were able to move the concrete objects from an equal groups representation into an array. They use those objects to create an array with spaces between the objects where they can see each equal group forms a row in the array. They talk about how the number of columns and rows help them identify the factors associated with the multiplication equation. Students also learn to take that array that they created with objects and draw a picture to represent the array. As they move to a more complex representation, students might go back to that array of concrete objects and move them together to show an array created without any spaces between the objects. This is an increase in complexity and will help them transition to drawing a rectangle that has a grid that shows the objects in the array. Here I can see the tiles like they practiced in 2nd grade, and I can see 3 groups of 4 tiles showing the grid on my rectangle. The final representation, which is the most abstract as students relate multiplication to area, is when they can represent the area as a rectangle that's open with no grid and the side lengths are labeled. Thanks for joining me for this video. Please check out more of our content videos and math resources on our website, pimaedu.com, and reach out if you want to schedule some custom coaching or professional development for your school.